Okay children, the topic is compound microscope, and this is the first case when the final image is formed at least distance of distinction, whose value is 25 centimeter, and numericals we take it minus 25 centimeter. This is the ray diagram in which you can see this is the object. Okay, it is very small object. This is the object, and this is the final image. This green one is the final image formed of the object using the compound microscope. In compound microscope there are two lenses. This is lens number 1, this is lens number 2. First is known as objective, second is known as eyepiece. Objective is towards the object and eyepiece is the one through which we see. And the distance between two lenses is called length of the tube, L. So this is one more diagram in which you can that I have drawn obviously. So this I have drawn so to show all the quantities that needs to be mentioned while drawing the diagram of a compound microscope. These are the quantities: h naught. H naught is height of the actual object. H dash is the height of image formed by objective lens. Okay, now this h dash is the height of image formed by objective lens, or it is the height of the object for eyepiece, because this particular thing, this is image for objective, but this is the object for eyepiece lens. So this, that is why I have written two names here, or karke you can see. Okay, then we have h double dash, which is height of final image, and then you need to describe these quantities also. What is u naught, what is u v naught, what is ue, ve, and I am taking ue as minus x and ve as minus d because that is the case. F naught, fe, l, these are the quantities that you need to describe. Then there is one more diagram. You can see here also all the quantities. For example, this is u naught. First of all, see, this is the object. Okay, first ray is going parallel, it is going through focus, so this is f naught, focus of objective. Second ray is going through optical center, it is going straight, and they are meeting here. So this is the image formed by objective lens. So this distance is u naught and this distance is v naught. Okay, u means object's distance from objective and v means image distance, and naught means from objective lens. Now this image is acting as object for second lens, right? So one ray is going like this. So this is the optical center of second lens. Second ray parallel will go through focus. Please draw in such a way that they are spreading apart. Now produce in back direction. So final image is formed here. Now this distance is known as distance of image from eyepiece, and its value is minus d. That is the case. And you can see this distance is known as object's distance from eyepiece, and this we have taken as minus x. So all the quantities you need to show, and it is also shown h naught, h dash and h double dash. Okay, so coming further, after proper labeling, we have to find out magnifying powers derivation or angular magnification. So m is the notation. It is the ratio of angle formed at eye by image when considered at least distance of distinction. This is according to the case. And lower one, angle formed at eye by object when considered at least distance of distinction. This will be fixed for both the microscope, simple microscope and compound microscope. Upper one is according to the case and lower one is fixed. So notation of both the angles I am giving as beta and alpha. Beta is upper angle and alpha is lower angle. So for smaller angles we know that theta is tangent theta. So beta can be written as tangent beta, and similarly alpha can be written as tangent alpha. So we are having our tentative formula for angular magnification or magnifying power. Further, what is alpha? Alpha was lower angle. So what was the name of alpha? Angle formed by the object when considered at least distance. So you can see I have drawn a triangle. This is angle alpha. This is some angle alpha. It is formed by object. That is a definition. It is formed by object. So this angle is formed by the object. This angle is formed by the object. And when considered as least distance, when it is considered at least distance means minus d. If you wish to show this alpha angle in the main diagram, you can show this alpha angle as well. At that time you need to cut a height equal to that of object. This height is that of equal to that of object, this object, okay, and then you have to elongate this, and then it will be alpha. Now rather than complicating the diagram here, I would prefer to draw a separate triangle so that I am clear about what is alpha. See, again I will show you that you have to cut a height equal to that of object, because this is least distance. It is an angle formed by the object, so this is an height equal to that of object, okay, and this is angle alpha. So rather than showing here, I am drawing a separate triangle for alpha. So this is my triangle for alpha, and tangent alpha can be seen as perpendicular by base, it is h0 by minus d. So just be ready and be clear that this minus d can anytime be written as VE in this case, because final image is formed by IP, so it is VE. Okay, for beta you have to go back to the diagram, and see what is beta. So I am erasing this. What is beta? Beta is the angle formed by the image. That is what we have written as numerator. It is the angle formed by the image when considered at least distance. So yeah, image is at least distance, so directly this angle is beta. Now this tangent beta can be written from big triangle also, this big triangle, and can be written from small triangle also. I would prefer it to be written by small triangle. This is beta, this is h dash, and this is your UE, which we have imagined equal to minus x. So my tangent beta would be perpendicular by base. You can write UE also, you can write minus x also, but later on. So we are ready with tangent beta, which is this h dash by UE, and tangent alpha is already h0 by minus d. Let us substitute h dash by UE and h0 by minus d. So this I am bringing here, keeping here. This I told you that this can be replaced by VE. See, so we have written. Now this is height of image, right? This is height of image, this is height of image, this is height of image, this is height of object. So this is magnification for objective lens, and this is VE by UE. V by U for lens is magnification formula. This is for eyepiece. So this is an important formula that we are ready with. The net magnification is the product of magnification by the objective and magnification by the eyepiece. Now we are opening this as using lens formula, magnification formula, V by U. So V0 by U0, and similarly ME can be opened as VE by UE. Now V0, so many times we have used in this case that final image, that is V by eyepiece, is formed at least distance, so it is minus d, and UE is minus x. Please substitute minus d minus x, this is d by x, so we are ready as it is. Now we are using lens formula for eyepiece, so it is 1 by V minus 1 by U is equal to 1 by F. E is denoting the subscript. Again third or fourth time I am using V is equal to minus d and UE is equal to minus x. So let us substitute. VE is minus d and UE is minus x, so it came this way. Now I am multiplying both the sides with d. Okay, so d will be cancelled, it is minus 1, it is d by x, and this is d by fe. So I am ready with the value of d by x. For what? Because I need to substitute this here. We need to substitute here. So magnifying powers formula I am ready with, which was V0 by U0 into d by x, is now d by x I am substituting as 1 plus d by fe. So this is the final formula. Now special case is V0 is limited up to L and U0 is limited up to F0. Okay, so we'll substitute in place of V0, we will substitute L, which is length of tube, and U0 is F0. The object must not cross F0. So that is why these are the limits. You substitute. This is the final formula for magnification in first case, angular magnification or magnifying power. Second case, when final image is formed at infinity. Who is forming the final image? You all know. Final image is formed by eyepiece. So eyepiece is forming the objective image at infinity. What does it mean? That means it is getting the object at its focus Fe. Okay, so diagram is simple. For image at infinity, you can see the rays, both the sides are parallel. Okay, so it is simple. Same angle by image, upper one is image when considered at, according to the case, it is infinity. Angle formed by object when considered at, so this is fixed, at least distance of distinct vision, so this is fixed. Now beta alpha same, tangent beta tangent alpha. For alpha, triangle is fixed already, so it is h naught by minus d. Okay, and for beta you have to go to diagram. So let us see what is beta. Beta is this is beta. So you can write tangent beta from here, perpendicular. Perpendicular, can you see? Tangent beta can be written as perpendicular is h dash. This is h dash. Right, let me erase everything and show you. See, this is beta first of all. This is h dash. Okay, and this is ue. And ue is by chance focal length. That is why image is formed at infinity. So we are ready with tangent beta, which is perpendicular by base. Base can be written as ue, but can be replaced by ue is equal to minus f. So we'll substitute tangent beta. Tangent beta we are ready with. This is tangent beta, which can be written as this. So on substituting both, we are getting this kind of situation. Now again it is height of image by height of object. So it is again magnification by objective lens, and this is d by fe. This is v naught by f naught. Again you will have to put the case, special case. Okay, so when we will put the case, it is L by minus f naught into this. So this is the magnification in second case. Both the cases are important, and thank you.